Well, welcome everyone. Good evening. My name is James Burk. I'm the Director of IT for Mars University and the Mars Society. And I'd like to welcome you to our program tonight on making humanity multi-planetary. With me tonight is Cole Lutz, who's our founder. You can see him on the camera there. Hey, Cole.
Hey guys.
And our first speaker tonight is Grant Anderson. Grant is the president and CEO and also the co-founder of Paragon Space Development Corporation. And he'll be talking to us about what a Mars base does not look like, as among other topics. Take it away, Grant.
Okay, so thank you for inviting me to this. I love doing these things, and this is a topic that I have a lot of thought about. I'm going to tell you that what I'm going to do is just give you a little bit of background of Paragon. This is not a sales pitch or anything, but I think it's also very important to kind of give everybody an idea of where I'm coming from. And I've been Paragon's 27 years old, so there's a lot of history behind us. And then really what I'm going to do is show you some pictures of, typical pictures. I literally just went on Google and said, give me pictures of Mars colonies or Mars bases. And I picked a few of them that I thought were representative. And I'm going to talk a little bit about, like Burke said, what isn't right. And this actually, for full disclosure, we got a call from the Design Museum in London a few years ago saying, hey, we're doing a special on Mars bases and we'd love you to be a consultant on it. So I actually consulted with them on it, and it just happened to be that I was planning a trip to London. My brother lives there. And so I stopped in and talked to him, and I said, okay, take every Mars base that you've seen and then throw them out. And because if you want this to be realistic, and especially in the design sense of the word, here's what's wrong with it. So this is a little bit of that, expanding on that a little bit, being a little more pointed about it. But if you were in London and got a chance to see that, it was on display from October of 2018 to February of 2019. I believe. No, it was October of 2019 and to February of 2020. Anyway, and then I'm going to be talking about some of the critical issues. I don't have any charts associated with that, but just talking about some of the critical issues of life support. So first of all, what's Paragon? Well, Paragon, it'd be interesting if I could do a show of hands, but it's harder to do on Zoom. But I often ask, how many people have heard of Paragon? We've been in business for 27 years now, started in 1993, around the concept of doing this. There was this really cool thing being built that was going to fly any day now called the space station. And myself and some friends of mine realized that, hey, there's really no good interface between the aerospace techies, of which I am. I have 2 degrees in engineering, and then biology and chemistry to make life science experiments on the space station. So we started off at that. We launched our first life science experiment in 1996 on the space shuttle that went up for a week, STS-77, I think it was. And then we went up to the Mir space station. So we went up on 79 and came down on 81, then went up on 86 and came down on 89. And during that time, we were the first, we accomplished the first capability of growing animals through multiple generations. So actually propagating animals in space, at least that was on record that we know of. There's a whole journal written about that. You can look it up on Google. I think it was written by the Japanese researchers we were working with. We also then in 2001 did the first commercial payload on space station. So we launched in February of 2001 on Progress 4, and we went up on the Russian side. And why is because the NASA side wouldn't work with commercial companies at that time, or rarely. And then the Russians, with only a few years under their belt since the fall of the wall, were willing. You showed them money, they would work with you. So if you remember that there was Popular Mechanics and Pizza Hut and a bunch of other commercial companies put some stuff up on space station. We're the ones who kind of forged the way or did the path with that and exercised all the protocols between the Russians and Americans and everything else. We've been involved in every single life support system that's ever been designed since 1997. The architecture of the Dragon vehicle is ours. In fact, Elon came to us with his PayPal money before he started SpaceX, and we were building a greenhouse for him for Mars. which is ironic to what I'm going to talk about later. And then tried to figure out how to launch it, got pissed at the launch industry and started SpaceX. So we helped them get through that. We actually wrote the capability D, which is the human aspects of Dragon 2. And also on the CST-100, we provide some hardware for that one. The Orion vehicle, we had almost 200 pieces of hardware of ours were on the first flight, and there'll be about 170 on the second flight when it finally flies. And then maybe some of you heard Red Bull broke the record for the highest skydive ever with Felix Baumgartner. What many of you probably didn't know is that 2 years later, Paragon broke the record again of the highest skydive in the world at 135,890 feet, but who's counting? And that suit, which you can actually see a picture of here, is actually in the Smithsonian at the Esterhazy out by Dulles Airport, and you can go see that spacesuit in the museum. And let me tell you, when your hardware starts showing up in museums, you feel old. And then we're going on forward. We're providing radiators for the Sierra Nevada Corp, and then we are on one of the 3 teams competing for the human lander system for the Artemis program for landing people on the Mars. We not only do space. In reality, Paragon is life support in extreme environments. Of course, space is the ultimate extreme environment, so about 70–80% of our work is associated with space, but we also do other things having to do with submarines and mining systems and other things where you can't survive without the mechanical and life support capabilities and working in defense and everything else. We're very much technology oriented. We've won the Tibbetts Award for Best Innovator in the Small Business Innovation Program before, among other awards. We have at least, well, actually now 20 patents or so. Anyway, so that's Paragon. So here's the meat of my talk. Hopefully what you can see here on your screen is, again, these are 5 semi-random shots of different Mars bases and Mars colonies that I pulled off the internet. I tried to attribute them wherever I could, and I apologize if they're not all there. But some of them will be familiar to you. The SpaceX one over here to the right. I think down here is actually the Mars 1 colony, I believe is what this one looks like here. Can you see my cursor, I should ask? Does somebody, Burk?
Yes, we can see it.
Okay, great. So what are some things you won't see on a Mars base? And the first one is going to be solar arrays. You'll see I point out some solar arrays here. There's actually some in this picture over here. There is a few of them over here. Solar arrays don't work real well. And if you need proof of that, just know that OPI, Opportunity, the rover on Mars, finally died because of a, excuse me, a dust storm. These dust storms are fairly common. In fact, we were very lucky not to have a long one early in OPI's life. But what a lot of people don't know is that when the dust storm happens in Mars, if you were to look straight at the sun in a dust storm, you wouldn't be able to find the sun. It's that dark. If you go search on the internet, you can find a picture that somebody published. I know I saw it at a conference at the International Conference of Environmental Systems in Albuquerque a bunch of years ago. There was an actual picture of the sun from one of the rovers during a dust storm, and it looked like there was an error because all it was it looked like one big black dot, not even a dot, a big black square on the screen. So if you don't have sun, and you might not have it for a few months at a time because these dust storms last that long, then you're going to be you're going to have something else that will provide electricity, because you won't be able to survive without electricity, which means you need a nuclear reactor. There's no way you're going to have batteries that will last long enough. And I haven't even mentioned the fact that dust accumulates, and very often what happens on the rovers that used to use, well, they now use nuclear power, the bigger rovers, but the ones that use solar arrays, like the Phoenix lander and a few others, is that the solar arrays would get so covered with dust, it would cut down the power output by almost a factor of 2. And the only thing they found out is that we're really lucky that every once in a while twisters go by and they blow off and clean off your solar arrays. The other thing here is the landing pads. Anybody who has been to a launch and has been to the closest place, what used to be known as I think it's still called the Banana River site down at Kennedy, or been involved with the Russians, they let you get a little bit closer if you've ever seen a live launch out of Baikonur. You're still pretty far away. And so when you've got this thing here with landers, on the side here, and some landers. You know, this one, it was a little hard to see if this was a lander. I don't think so. This was actually a structure of some type. But even these landers that are a decent distance away, but I'm still saying they're pretty close. If you had a error, mainly in landing and coming down, and you're approaching one of these pads and something goes wrong and you blow up, you're going to pepper the area with shrapnel. And if you've got any structures outside, there's a good chance you're going to pierce a few structures with the velocity of things that would fall. In fact, this one over here I thought is really interesting because it looks like they have a launch pad right here. And if you look at the scale, you can blow up the picture a little bit. You know, this is about 150 yards between these two things. Anybody who's been to a launch, like I said, they keep you a good few miles away. And there's reasons for that, because things can go off course and have to be blown up and everything else. So that's one thing. Greenhouses themselves, I've already talked about. Having clear greenhouses doesn't make any sense because you're going to be cleaning them off all the time. And the other thing that is that the noon solar insolence on Mars when you're on the equator is roughly, give or take, 60, 65, 67% of what it is on Earth. It's not only the squared law of distance, that of course Mars being so much farther than Earth that it cuts it down. There's actually a benefit though, the Mars atmosphere is so much thinner that actually raises your solar insolation. But even then, it's still less, or just barely enough to get a plant to senesce, which is a technical term that means to produce seed. And very often when the plants that you talk about, you need the seed because that's what we eat. You very rarely, like with peanuts, you can eat the peanuts, you don't eat the greens. They're not digestible by humans. So if you want something to produce the seeds, and that includes trees, fruit trees and stuff like that, they've got to have about 800 micro-Einsteins per centimeter squared per second. I think I got the units right. And that's barely where you are on a solar noon. And believe me, we had to know that when Elon Musk came to us and asked him to build a greenhouse long ago. And then the other thing, emergency operations in EVA, one of the things about building a base, and this is not really well thought out, in fact, we've been trying to get NASA to do a little more work on this, is that your emergency operations are what dictate a lot of what you can do on an EVA. You'll notice with the Apollo program, EVAs were only certain distances away from the vehicle. It was how far you could get back. And you could only go so far in a rover without having to get back. And there's certain considerations of where is your airlocks? Where can you get to your airlocks? If you're out at the edge of these solar arrays, cleaning off a solar array, how do you get back here if you have a suit emergency and things like that? And then finally, radiation protection, or as I would say here, lack thereof. These plants wouldn't fare really well with the amount of radiation because, of course, you have the thin atmosphere. I will maintain that the first bases, not only on Mars, but on the moon, will be in lava tubes, or at the worst case, they will be covered up with regolith, as you do see in some artist renderings, in order to protect you from radiation, because the long-term radiation and the galactic radiation associated with events, well, galactic radiation will go through anything almost anyway. You need regolith to stop it. But even solar proton events, you're going to need some protection. So I would maintain that if you do have any surface structures, they're going to be airlocks that lead down into something underground, or at least, again, covered with regolith. So that's really all I had for pictures. I forgot to point out here, I thought this was a really good picture down here in the lower right corner. This won a design contest for Mars. It was essentially a 3D printed beehive, for want of a better term. And it was more realistic of what you might see on Mars. It still had on the top a glass dome. It was actually a glass lens that would have water in it to protect you from the radiation. This is maybe getting a little more realistic, but again, I think you would have a small, medium-sized nuclear reactor. And I will say we will never colonize Mars unless we have the capability to plunk a medium-sized nuclear reactor on the surface, because again of the dust storm issues. So Burk, that's all I had, and I'm at the 15-minute mark according to my watch. So I'm going to hand it back to you, but I'm going to stay around as long as I can for questions afterwards.
Thank you so much, Grant. I have a question before I turn it over to others for questions. Can you talk a little bit about what the logistics of setting up a lunar tube as a base? Like, how would that actually work? Have you thought about that?
Yeah, and as a matter of fact, one of our employees, Bailey, oh, what's Bailey's last name? I've forgotten now. She actually participated in the Mars study at the Hawaiian site, and actually one of the things they did is explore a lava tube. I believe what we will end up doing. I don't think it's going to be practical to build a structure that will act as an airlock right into the rock, because we just don't know the morphology of the rock. We don't know the strength and materials of rocks. We don't know if rocks will crumble at the touch. Within reason, we do know now that we've drilled into a bunch of them. I think what will happen is we will take along an inflatable structure, and we will go into a lava tube and essentially inflate that inflatable structure. Now you don't have to worry about micrometeorite protection because you've got the regolith around you and above you, but it will allow it to hold pressure and everything else. So you'll still have an airlock inside. You're going to have lights that won't do you any good to have windows in the lava tube unless you also put out lights. So that's, I think, how you were gonna do the lava tubes. Is an inflatable structure underground.
Speaking of windows, have you ever heard of the concept of a Z window, where you basically have a couple of angled mirrors and you're able to make it actually functions just like a window, although you're still underground. Have you ever heard of that concept?
Yes, yeah, and there's that, and then there's light tube concepts where they take a bundle of optical fibers and project it down. That's good for doing light. It's not really a way to look out. With the Z windows, you can look out. It's a good way to not have a direct radiation source coming in. That's true. I will say, depending on what your radiation is and how it propagates through the atmosphere, which I am not an expert on, the question is whether it would mitigate it enough. I would assume so, but I'm not an expert in that area.
Mm-hmm. Okay, let's ask a couple questions from the audience. So Michael Jackness asks, do you have any direct business competition?
Oh yeah, a few of them. One of them is what used to be known, depending on how long you've been in the industry, they've been known as Hamilton Sunstrand or Hamilton Standard before that. And then they became UTAS, United Technologies Aerospace Systems, and then Collins. And now they are actually part of Collins Raytheon Technology Systems, I think is the official name of the thing. So they're probably our biggest competitor. They built most of the internal structure associated with the air life support on space station. The other one is Honeywell, and Honeywell built most of the thermal life support for the space station, the cold plates. They didn't build the radiators. The radiators were actually built by Rocketdyne Corporation. And then some of the new space startups. You know, Jeff Bezos's net value went up by 70 billion last year, while we were all suffering through COVID. Just keep that in mind when you go and buy something from Amazon, which I won't do as a matter of pure spite, maybe. And Elon, you know, they could sell 5% of their stock and finance a whole system. So I'm always worried about those guys getting into that. I'd say we work with Elon. We have worked indirectly with Blue Origin. He stole away my director of research and development a few years ago. I could offer $1 million of R&D spending, and he could offer $1 billion. It's I don't blame her for going, but so those are my big competitors. In the international world, Alania Spazio out of Italy. They're the ones who did most of the life support system for the Columbus module, and then they also do the rudimentary life support system for the Cygnus vehicles that are the pressurized cargo containers that Northrop Grumman sends up to the space station. So.
Bruce, do you have a question? Looks like your video's turned on. Okay. Next question is from Joseph. Is that Sweeney? Sorry, it's cut off on Zoom. So his question is, what are your thoughts on the feasibility of terraforming Mars in the long term?
One of the things you learn in my business is never say never. You know, the issue, I think the biggest issue is the density of the atmosphere and how you raise that. I have never done the calculation myself, but I think if you take the the planetary surface of Mars, which coincidentally, the surface of Mars and the dry surface of Earth are pretty equivalent in total square miles. And then, look at whatever you want to say, 2 or 3 miles of atmosphere. That's a lot of gas to go from. Right now, the pressure altitude on Mars is 1/100th of an atmosphere. It's about the equivalent of 120,000 feet in the air in Earth. And yes, we've built, because we held the record for the highest skydive at 138, we built spacesuits that can do that. But filling up that atmosphere, now you would never need, of course, a full atmospheric pressure. Mind you, if you put the same density as on Mars, it's on Earth because of gravity and everything else, you would already be down in the single digit pounds per square inch. And now then you start talking about having an atmosphere that has enough partial pressure of oxygen, which is generally, we don't like to see anything below 2.8 and would rather have a little bit more pounds per square inch of oxygen. So you might be looking at a 30, 40%, 50% oxygen atmosphere in order to breathe it normally like a human. Now you start getting into flammability concerns. There's a good reason why the Earth is at 21% and not 30%. Mind you, not a lot of things become more flammable, but they burn a heck of a lot faster and would be much more destructive. If you want to see the forest fires in California this year multiplied to the extreme, have a 35%, 40% oxygen atmosphere. And then of course, that doesn't even mention moisture, and things will escape faster. You don't have the gravity and stuff. So it's taken billions of years for Mars' atmosphere to go as thin as it is, but it's still a decent factor faster to lose atmosphere on Mars than it is on Earth.
Next question is from Evan Plantweir. Hi, Evan. At this point, is there much confidence that lava tubes have sufficient structural integrity for placing outposts inside?
I've had a conversation with Peter Smith, and Peter Smith was the PI for the Phoenix lander, and he thinks so. And then the Lunar, Planetary Sciences Institute is here in Tucson, and there's a few people I know there, David Crown for one, and they also think so, because most likely they are lava tubes, which means that they've had a natural, when a lava tube gets created, lava has to go through it, and it kind of creates its own walls. So I think it will be a slightly more brittle structure, but that's my unprofessional opinion. But when you're under a meter or two of that, that's a decent amount of weight that will hold the structure, make your tube actually stronger than if you were. And then again, this gets to are you going to inflate it directly, or are you going to use an inflatable structure inside? The reason we know there's lava tubes there as well as the moon is because we can see collapsed lava tubes. There are very distinct pictures. I think if you Google lava tubes on Mars and lava tubes on the moon, you will get a few pictures. So they do collapse, but we have one record. I think there's one on moon that goes tens of kilometers, and you can see it's collapsed in some places. In other places, there are like little skylight openings. There's no reason to think that the structural integrity is anything we'd have to worry about in the near term, I would guess is the way to put it.
Mm-hmm. Next question is from William Knopper. Is drinking meltwater reasonable from ice naturally occurring on Mars?
If you dig, I mean, the polar caps seasonally develop a coating of CO2 because it gets cold enough to freeze out the CO2 as well as the ice. And I guess my real short answer is not without cleaning. And truth be told, Paragon does and has the technology. We have a program right now run called IHOP, which stands for in situ hydrogen and oxygen production, which is actually a method for taking ice on the moon and cleaning it to rocket ship standard, which is actually pretty pure hydrogen and oxygen. And of course, in order to do that, you should start with pretty pure water. There are also worries about contaminants messing up your electrolyzer that divides the hydrogen and oxygen molecules. Mm-hmm. The problem I think you have on Mars is the amount of perchlorates in the dust. and the amount of salts and stuff that are we think are there, that you would, I would not advise, and I would doubt, and nobody would ever send somebody to Mars without a good water purification system and say, go drink the ice. You're gonna
Yeah.
need to. And oh, by the way, if you might dig up some ice, bring it inside, and then melt it in a pan to boil your eggs, it might off-gas something that's might be pretty deadly with, you know, with perchlorates and stuff. So, and I am not an expert on the hydration of perchlorates and whether that breaks down quicker or anything like that, but that's why I employ some chemists.
Next question is from Christina. Would wind energy have a chance on Mars?
Not really. You know, a lot of people remember from Mars, The Martian, the movie The
Yep.
Martian, where once again we saved Matt Damon. You know, it seems like, you know, Saving Private Ryan, The Martian. You just name the picture, and we're always saving Matt Damon.
Interstellar.
Interstellar, right? Exactly. You know, the whole thing, the whole premise. I had a conversation with Andy Weir one time, and he said, Andy, what you should have done is make it a biological thing, and that some biological thing went through and he was presumed dead and then actually recovered. That would have been better than a windstorm, because again, I'd mentioned that the atmosphere is 0.01 of Earth, a 100th of Earth atmosphere. The power that is allowed, that you can extract from air, is a function of density squared. It's the dynamic pressure you can get. I'm sorry, velocity squared. So it's 1/2 the density times velocity squared. And when you're talking with a density of 100th of amount, that means your velocity has to be pretty high, and the winds don't get that high. So the whole premise of the Martian of this thing getting blown, well, for one thing, that the rocket gets blown over, so they have to take off before the rocket gets blown over, is total fantasy.
Yeah.
Well, you have the same problem if you pull out an engineering textbook. The amount of power you can pull out of wind has to do with, again, the 1/2 rho v squared, plus also the diameter of the wind turbine. And to pull out appreciable energy, you're going to have a big rotor, and it's not constant. So again, you get back to, well, if it's not constant, you need a nuclear reactor, just like when the sun's not constant. And I will say one thing, I get asked all the time, what's the most unrealistic thing about The Martian, the movie? And most people are expecting me to talk about the wind, the whole idea of the wind knocking over the rocket. What I usually say is the most unrealistic thing about The Martian is how modern the NASA buildings look. There's just, you know, and the amount of technology, you know, if anybody who's been at a NASA facility, if it's built past 1970, it's a new facility. I've joked about the fact that a NASA facility, they've gone through this little thing where they were cinder block structures, many of them taken over from NACA, the NACA, before the precursor to NASA. They were built in the 30s. They look like a concrete, they look like government buildings, right? And it was really funny because sometime in the 1970s and 80s, and well, more in the 80s and 90s, there's trays started to appear in the hallways so they could string Ethernet cables down these trays to get Ethernet to everybody's desk. Well, now those are disappearing again because Wi-Fi is getting fast enough, except for those people who do heavy computation. So the Ethernet cables are disappearing. So it's actually coming back to what they looked like in the 1930s to 50s when they were built.
That's funny. A question from John McCabe. Assuming we build with Regolith on the Moon and Mars, which process do you think is the near term compared to the long-term solution? And he gives some examples: solar sintering, biopolymer, microwave sintering, bio-derived binders.
Wow. Yeah, that's a very, very good question. So I think in the near term, regolith is going to be just piled up. And then it comes down to what's your angle of repose. And for those of you who are civil engineers, you know what that is that given your gravity and your morphology of the material, you will have a natural slope that it will eventually go to, that if you get steeper than that, it will collapse. And if you get shallower than that, you're wasting space, or you're wasting putting up a lot of stuff. But I think the first ones will be, if they can't find a lava tube, or they want to have a very specific place that doesn't have lava tubes around it, they will put down some sort of metal structure and then cover it with regolith. And then it's a matter of the mechanics of of actually bulldozing the stuff and dumping it on top and getting it thick enough that way. And there's tricks to do that. You can make structures on the outside that are fins and stuff to catch the regolith so it will hang better. In the longer term, there's actually a cool company called Redworks, and you can look them up. And they do a sintering method of taking sand and making 3D houses out of it for, and I think doing that, sintering it with some sort of a solar concentrator will happen before the binders or the bio binders, just because of the mass you need. Somewhere your binders have to come from somewhere. Organic binders means you're going to have to import them until you've got a industry that can grow a lot of lignans and other things, the woody parts of plants or whatever. You're going to probably need to sinter, because you really don't need to bring mass. You assume you can melt and together the regolith. Once you get up, if you can bring binders and stuff like that, I can definitely see that. In fact, I have everything I say has a little bit of controversy, because I tend to make statements and they all have subtlety and gray areas, and that's why I love giving these presentations. You don't have to get down into the calculations, but I've often said that one of the first more advanced things you grow on Mars should be bamboo, because if you take bamboo and then embed it in a resin, you have some of the best structural beams you can ever build. So that is another option on Mars to actually, if you can grow stuff and if you can grow it with adequate lights and stuff, bamboo grows extremely fast, sometimes in the order of feet a day. It's a very well understood thing. You then cut it, put it in a mold, dump some resin in it, and now you have an extremely, extremely strong and versatile beam. And you can use those as beams then to hold up regolith, and you can do a fair amount. But the problem there is the mass. So where does the glue come from? There's again, not being a chemist, there's not a lot of chemical formulas I know for resins and epoxies that don't have some sort of high chemical base industry behind them that you probably would not have the capability of producing on Mars in the near term, at least.
Mm-hmm. Okay, it looks like we have time for one more question for Grant, and that's going to be from Aiden Levy. What do you think the necessary properties are to create the best analog, Mars analog, here on Earth? If you had a chance to create a Mars analog, what would it look like?
Well, yeah, and we're involved in one right now, actually. The Desert Research Station and frankly the analogs they do on Hawaii are all very good. I like the Hawaii ones better than Devon Island because of the altitude, so at least gives you a little bit of what it, having to worry about whether you have enough air to breathe, which is always a good psychological thing to have. I think one of them is the whole provisions for EVA and for simulating. What's really hard to simulate in any colony structure is the isolation. One interesting thing about Biosphere 2 here, I'm in Tucson, Arizona, and just north of us, I can ride it on my bicycle in 2 hours and get up to the Biosphere 2. One of the interesting things that a Russian cosmonaut said about Biosphere 2 is, yes, but you can always get out. And so one of the things about a Mars colony, until it's terraformed, of course, definitely a moon colony, is the outside environment is so harsh that there's just no way. It's one of those things, the joke, if you see fingerprints on the outside of your window, you're in trouble on Mars or at the moon. That psychological aspect of isolated living, which is known in overwinter analogs in the Antarctic and stuff, to cause psychological problems, to actually cause. I know that I've talked to people who were in the biosphere. In fact, full disclosure, 2 of my people that I started Paragon with were in the biosphere for 2 years, Jane Pointer and Tabor McCollum. They actually had hallucinations associated with the extended isolation, and they had 8 people in there. So that psychological aspect of living isolated is really hard. So I would make a Mars analog where, except for extreme purposes, you cannot get out. you know, make it permanent, you know, weld the door shut. Obviously, for safety reasons, everything else, you can't do that. But the protocol has to be pretty amazing to get that psychological aspect. The other part is I don't think enough of simulating the communication aspects with the Earth are done. The delay in transmission, the cycling of from 10 minutes of a one-way talk to a 45 minutes, depending on whether you're near conjunction or whatever, you know, the farthest and nearest parts. You know, the Vince Cerf, when I was talking to him, you know, the internet won't work between Earth and Mars, right? Because
Right.
IP protocol has to always do error checks, and you don't have that capability. It only works if you have a limited number of microseconds between spots. So you're going to have this one-way dialogue, and I talk about this. I did a TED talk for in Orlando. In Orlando, it was called the Winter Park TEDx in Orlando, Florida, and really, you get more than 5 seconds away from Earth, you cannot carry on a conversation anymore. Theoretically, yes, you can if you're very disciplined, but all of us here that have been doing Zoom for a year know that if anybody, you know, pauses to take a drink of water, the conversation falls apart. So think about that if it's 5-10 seconds all the time. So I think getting the communication down, the isolation, you won't hear from your family except in video snippets. You won't respond to them except in video snippets. I think the psychological aspects are the most important. They're doing a pretty good job on the physical aspects of the analogs.
Yeah, and I'm pretty familiar. I'm going to go into it during my portion of our seminar this evening, but the Mars Desert Research Station, yeah, it's really easy to break SIM, and people do it a lot. You know, they get a hangnail and they want to break SIM. And I know that the Russian Mars 500 experiments were more what you described, where they were locked in and they really couldn't leave unless someone was going to die. And I think one person even got a broken arm or leg in there, and they were able to just put them in a splint and keep the mission going. So yeah, it's definitely it's a low fidelity sim if you could leave it. That's for sure.
Yeah.
Awesome. Well, thanks so much for your time today, Grant. We really appreciate your thoughts and your perspective. And you're welcome to hang around. I'm going to go into my half of the evening now. So again, I'll just reintroduce myself. My name is James Burk. I'm the IT director of the Mars Society and Mars University. I'd like to talk a little bit about the Mars Society and how we are working to make life multiplanetary. The Mars Society, we've been around since 1998, and I'm a founding member. I was there at the beginning. As a matter of fact, a couple of years before that, I was on my way, had just graduated college. I was on my way out to Seattle to start my job at Microsoft. And I had a book with me, and it was The Case for Mars by Dr. Robert Zubrin. And read the book, was very inspired by the book. And when I got to Seattle, I found out that the Mars Society was starting up, and Dr. Zubrin was the president and still is the president. And I joined, and it's been a wild ride. I've been involved since the beginning. I've been the Seattle chapter head since that time, and I got the opportunity to come on as the IT director in 2011, so about 10 years ago now. And it's been a great run for me. So what is the Mars Society? Well, there's a flag behind me. It's called the Mars flag, and it was designed by Pascal Lee, and it represents the past, present, and future of Mars. And it's a flag that we proudly fly at our events and at our research stations. Grant mentioned we have a research station called the Mars Desert Research Station in Utah. We also have one called the Flashline Mars Arctic Research Station that's up in the Arctic in Canada on Devon Island. That was actually the first one. We built that in the year 2000. And we built the MDRS in Utah in 2001. And we've been operating the MDRS continually since then. Now, COVID did put a pause on our operations, but we are starting up again very soon. And I'm going to be on a crew actually in December of this year. I'm going to command my first crew at the Mars Desert Research Station. I have a few crew members that are from France and Belgium that are going to be with me. and we're already studying which experiments we're going to do. We're talking to other researchers and folks in academia and folks in companies about what experiments we could take with us. And it's very exciting. I'm very, very proud to be able to help the worldwide analog research community with our mission. And you know, the Mars Society, what we stand for is Mars, is going to Mars and settling Mars. We don't just want to go there and plant a flag like Apollo 11 and come home. We want to go there to stay. And that's been our mission as an organization since the beginning. And the Mars Analog Research Program is just one of the things that we do. So let me pull up our website, and I want to show you a little bit more about the Mars Society. So this is our main website. I actually developed this site, and you can see if you go under projects here, there's quite a few projects that we do. I just mentioned these two. We also have the University Rover Challenge. This is where students around the world will work on a rover design, and then they'll come to Utah and they'll pit their rover against an obstacle course and try to win the competition. And this is competition we've been doing every year, and we've had thousands of people come out to Utah to participate in it, and we're looking forward to having it again, hopefully in May this year. Although we might have to punt in another year because of COVID, things don't improve. The Rover Challenge we do is also spawned the European Rover Challenge. There's also one in India. And so this has turned out to be a great thing for university students and others to learn more about rovers and how we can explore Mars robotically. I also work on this next project, which is called Mars VR. So I'm going to pull that one up. This is, we basically take in the Mars Desert Research Station, which is a real life facility, and the terrain around it, which looks very Mars-like, and we've turned it into a virtual reality application. And so you can walk through the buildings inside the MDRS, and eventually you'll be able to even do some training and learn how the real crew members that go out to the MDRS, what they do for some of their basic tasks and learning the facility themselves. So this is a project we've been working on for a couple years. We did a crowdfunding campaign on Kickstarter in 2018 to get the project going, and we'll be starting up another one later this year to finish that application out. We will be actually giving this away for free when we're done, and we'll be open sourcing it so that all the schools and museums around the country and around the world can experience the Mars Desert Research Station in VR. And I've had the opportunity to take this VR app and show it at different events here in Seattle, as well as at our conferences. And the response is always very positive. People love being able to walk around on Mars and kind of experience that. At one time, I was able to take several hundred middle school girls that were underprivileged here in Seattle through the experience, and they just were blown away. They didn't expect to get to do that on that day. So this is one of the ways the Mars Society is trying to get the word out about humans to Mars, about settling Mars. And it's all about getting the public behind and in support of a mission such as this, a program such as this. Grant mentioned the Martian movie in his remarks. That was an inflection point for us. We really noticed that before and after that movie, things changed. That movie really showed the general public that a human mission to Mars is not like a science fiction thing that would happen 50 or 100 years from now, that it's actually a near-term mission that we could actually do. We just need to have the will to go do that and the funding to go do that. Another thing that's really been exciting, looking at the Mars Society over the last 23 years, another thing that's been really exciting that's happened is SpaceX and Elon Musk. Elon Musk was actually on our board at the Mars Society back in 2002, right after he sold PayPal. And he was thinking about what to do next. He hadn't founded Tesla yet, and he hadn't founded SpaceX yet. but he was talking to Dr. Robert Zubrin about doing a private Mars mission to land a greenhouse on Mars. And he'd say, I want to have sort of the money shot of green plants growing with a red Mars background, and that would help increase funding for a Mars mission, because he kind of had the same goals that we do. He wants to see human beings go make life multi-planetary. And so Elon, you know, to pull off his greenhouse mission, well, he's like, well, I need a rocket, so I'm just going to go fly to Russia and see if I can buy a couple of ICBMs, because that's what normal people do. And the Russians, unfortunately for them, were very rude to him. They did not sell him an ICBM, and so he started SpaceX. And it's a funny story is that Dr. Zubrin once tried to talk him out of starting SpaceX, because he had just seen another entrepreneur start a company called Beale Aerospace. And Andrew Beale had spent his whole fortune starting that company, and it failed. And so he didn't want Elon to do the same thing. But the difference between Elon and Andrew Beale is that Elon actually taught himself rocket science, and because Elon is not a normal human being. But he was able to do that, and he was able to start SpaceX. And they'll tell you, the folks at SpaceX will tell you, things were really dicey when they had those 3 failures. And they had that last mission that was going to be their last shot, but the Falcon 1 rocket succeeded, and they were able to get the big NASA contract to do everything they've done since, the Falcon 9 and the Crew Dragon. And now they're breakneck working on Starship. Starship is such a cool project. They're not just building one rocket, they're building a rocket assembly line down in Boca Chica, Texas. And I and a lot of others feel like that's really going to be the thing that opens up the solar system, is having Starship reusable rockets available that are low cost, that you could use to go to the moon and land a lunar base and go to Mars and start the Mars colony. And we're actually going to see that in our lifetime. I believe that very much. In fact, I think we're going to see it at this decade, some of that stuff start up. So the Mars Society, the last couple years, one of the things we've tried to do to stay relevant is we did a Mars colony contest. We threw out a call for papers for a Mars colony, and we'd have a $1,000 cash prize, as well as some other prizes. I think actually it was 10,000. Several cash prizes to the best entrants. We were completely blown away by how many great entries we got. And we had over 100 designs came in for Mars colonies. And so we ended up printing this book called Mars Colonies that you can get out on Amazon. It's also available as an ebook on Amazon. And Dr. Zubrin took this book down to Boca Chica and handed a copy to Elon as soon as it was ready. And we recently just finished up the second contest, which was the city-state contest. And that's going to be a 1 million person settlement, whereas this one was a smaller, sort of less than 1,000 person settlement. The city-state contest is like a 1 million person, and that one just finished up. We announced the winners at our last conference in October, our virtual conference we did, where I actually got to interview Elon Musk, which was really cool. We had 10,000 attendees at that conference in October. All of that's up on YouTube, all the sessions, so go check that out, the Mars Society's YouTube channel. But we're in the middle now of doing the sequel to this book and printing that out, which will be the city-state design contest book. So trying to stay relevant, trying to keep the torch burning, and making sure that the Mars Society has a role in our inevitable colonization of Mars and settlement of Mars. So with that, I'd love to throw it open if anyone has any questions on the Mars Society and how you can get involved. And then after we're done with a couple questions, I'm going to throw it to Cole, and he has some announcements on Mars University. So if anyone has any questions, feel free to unmute and go ahead and ask. And turn on your video if you'd like. And
Hi,
also,
James. I just wanted to say thank you, first of all. And second of all, I just wanted to say, you know, if I was interested in joining the Seattle branch, for example, how would I go about that? What is that process like? I'm a local, so to speak.
Yeah, absolutely. So we have chapters all over the world. I lead the Seattle chapter, and each chapter, you can think of it as a mini Mars Society. It's a mini independent organization. You can go to our website and go to the chapters section. Essentially it's chapters.marssociety.org. I can actually type it in here, chapters. And you'll be able to find your local chapter. Either on Facebook or on the web. Let me take the S off there. Looks like I got to fix that. So here's the map of the world, and you can see there's all these different chapters around the world. Like there's a really big one in China. And they have a Facebook group over in Germany. We've got Mars Society Germany, Deutschland. And then if I go into US, there's going to be quite a few there. And we actually have our own little map there for the US. But yeah, if you contact your local chapter, you can find them on Facebook, you can find them on the web in some cases. So here's our website for Seattle. A lot of them will publish their meeting schedule. So before COVID, a lot of us were meeting in person. Here in Seattle, we have a Zoom call every month now that we have jointly with the National Space Society chapter. Both chapters meet. And so just get involved. And if there's not a chapter where you live, so you can start one. And we'd love to have you. So there's all the information on this site about, on the chapter site, about how to start a chapter. And you can look at that information there and fill out the form, and you'll be on your way to Mars.
Okay, perfect. Thank you so much for your time.
Yeah, thanks, Luke. Any other questions? It says host disabled video sharing. That's weird. I didn't do that. Let's see if I can turn that off. Any questions, feel free to unmute while I figure out how to fix Cole's video. There he is. Okay, well, thanks everyone. I'll turn it over to Cole now, and he's got some stuff to talk about with Mars University, which I'm very excited to be part of, by the way.
Thanks a lot, James and Grant, for speaking today. Learned a lot, and I think what I love most about Mars is this shared belief in the impossible, and I think what Mars U is really about. It's about enabling you to better find your focus and passions. I think that can really be invaluable. And it's kind of unheard of to most people to imagine dedicating your career and research for something that you've never seen. I think that's the beauty of nature and the human race. And some announcements. We're planning a seminar next month about perseverance and the landing after February 18th. So excited for that, and keep your eyes peeled for that one. And also, if you have any suggestions for future seminars or topics for these monthly meetings, feel free to let us know, because we'd love to help coordinate in advance.
Awesome. All right, well, thanks, Cole, and thanks, Grant, if you're still on, and everyone that's joined. I hope you guys keep Mars on your mind, and we'll see you soon.
Yes, thank you very much. And somebody asked if I'm hiring, and yes, Paragon is hiring. You can go to www.paragonscc.com, and you can go to our careers and see spots there.
Awesome. Thanks, Grant. Okay. All right, everyone. Have a great evening. We'll talk to you soon. See you on Mars.
Goodbye, everyone.